Hi, David Mason here with Nobles Consulting Group. I just wanted to go over a couple of considerations before we fly. First, we need to specifically identify the area of interest. In this case, it is right around the Woodville Community Center. We need to take into account how close we are to an airport, how high it is necessary for us to fly to capture the data that we are interested in, the openness of the area for establishment of ground control points, and any other people that might be around in the area, or cars, or etc. So before we can come out here and fly this, those are some of the things that we need to take into account. So now that we've come out and we've set our flight path and we've flown it, so what do we do next? What do we do with all those photographs? There are several different options or software packages out there that are capable of handling the photos and ground control points. They include but are not limited to ActiveSim, Photo Modeler, Agisoft, and Pix4D. We chose the Pix4D Mapper Pro. The reason for that was it's just to me, to us, it seems a little more intuitive in its use and how it's used. So we're going to open Pix4D Mapper Pro up and start a new project. Then we add our images. I have already gone through and selected the images that I wanted to use. We'll load those up. And we have 218 images selected. This shows our image coordinate system. We have 0 of 218 images geolocated. This is because our UAV does not tie its GPS coordinate information to the photograph in the EXIF of the photograph. It identifies the selected camera model for us. The warning indicates that we don't have any photos that are geolocated. And we finish. So we have this nice map, and we need to decide here, what do we want to get out of our data? So we go to our options, and we're going to use aerial nadir, which indicates the camera was pointed straight down at the ground. We're going to rematch images. We're going to use the original image size. For our point cloud, we're going to, for our filter, we're going to use a densification area. We're going to generate a 3D textured mesh. With a maximum number of 1,000,000 triangles. We can output an LAS file, an LAZ file, a PLY file, or XYZ. For a 3D textured mesh, and we can output a PLY, an object file, or a 3DF file. We chose the 3DF in the LAS. And for the digital surface model and ortho mosaic, we're going to use a little noise filtering. We're going to use surface smoothing. We're going to create a geotiff with the tiles that are merged. Some additional outputs include contour lines that could be output in shape, PDF, or DXF format. So those are the output options that we have selected. So now we're going to bring in our ground control points. We're going to go to the ground control point manual tie point manager and select our coordinate system. And our coordinate system is North American datum 1983, Florida north feet, and now we're going to import our ground control points in a YXZ format. The GPS data was converted to a text file. Just going to browse and pull that in. This takes us into, kind of zooms in on the area of interest and identifies where the ground control points are. This is ground control point 3, 4, 5, 6, 7, 8, 9, and 10. This is ground control point 3, 4, 5, 6, 7, 8, 9, and 10. So now what we need to do is identify the ground control points in the photos. So we go back to our tie point manager and we'll select the ground control point. We're going to start with 4. We go to basic editor and you can see it opens up another frame or window where you see the list of photos, list of ground control points, and the photo itself. So we're going to see if we can't find a photo that has a ground control point 4 in it. We'll scroll through the photos. This pretty much follows the flight path of the UAV. And we want to pick ones that are almost directly above it. And here is ground control point 4. So we selected the center. And so on and so forth for each ground control point that we have listed. We'll find the corresponding photographs and identify those control points in the photographs. You can see that the red crosses are still there, but we have one blue one. The blue one is the one that we have identified photos in. Now to expedite the matter here, we're going to open up an existing file of the site that's already been processed. As you can see here now that all the ground control points are blue, which indicates that they have been identified in corresponding photographs. What we're looking at now is the map view. I'm going to go to the ray cloud view, and what you see here, the green dots that we see here, is the flight path. These are the location of the photos of the position of the UAV when the photograph was taken. Where you roll up under it and scroll in a little bit, you can see the photo. The points that we see are the tie points that were used to tie the photographs together. We're going to turn those off. Just with the tie points, you can pretty much see the outline of the parking lot and some of the other features. So from here, we're going to turn on the densified point cloud that was created. This might take just a moment. So now we have our point cloud loaded. And you can see the detail. So now that we have the point cloud loaded, you can see the detail that we have from the point cloud. You can identify where the ground control points are. This is ground control point number 3. Number 4 is to the right. We also have, you can information about each point that you would like to pick. So we'll select a point at the end of the line, the stripe, and it identifies where you selected in the photos and gives a coordinate and elevation and the number of images this particular point was visible from. So now we're going to open up the mesh that was created, which might take just a moment. Okay, now our 3D mesh has been created, or loaded, excuse me. Which corresponds with the 3D PDF that was created. And one of the other outputs is the ortho mosaic, which we will open up in ArcMap. And this is the ortho mosaic that was created from the flyover. You can see our ground control points. This is 4 and 5. And that pretty much sums up the processing. One thing to keep in mind that in processing the photos, it takes that particular amount of photos. It took about 4 hours for the software to stitch all the photos together and create the outputs. But if you have any questions, please feel free to ask. Thanks for listening.